Atomic force microscopes are able to map small changes in the height of a surface of a sample with incredible accuracy and resolution. One means of doing this is through contact mode feedback using a sharp tungsten needle. The needle is mounted at the end of a cantilever. When the tip encounters a change in topography, the tip will either be deflected up or down, causing the cantilever to bend relative to the engage point. By reflecting a laser off the cantilever and monitoring the reflected laser position, the topography can be recorded and mapped. Using piezoelectric crystals to scan in the XY plane, a two-dimensional topography map can be created. In contact mode, when the cantilever bends and the laser is deflected up or down, a piezoelectric crystal responds by moving the tip up or down, bringing the laser position back to the original spot. This keeps the cantilever at a constant deflection, and therefore a constant force. This property is essential to a long tip lifetime for AFMs. Contact mode allows two additional important imaging modes: conductive AFM and scanning capacitance microscopy. Since the conductive probe tip is in contact with the sample surface at all times, electrical data can be acquired. The multiprobe AFP system utilizes contact mode AFM imaging and allows up to 6 AFP heads. The heads scan in unison with one another. The user is able to set the probe tips very close together in order to scan over a common region with each tip and create an overlay map, where the position of each head is known in relation to the others. This allows an engineer to scan in a memory or logic array and be confident that the devices he or she sees are the same in each image. The snap sample stage is able to move from one point to another with an accuracy of less than 50 nanometers using piezoelectric crystals. The engineer can use a CAD/nav program or bit location to drive the sample stage to the fail site with confidence. Once at the region of interest, the user scans the area and lands the probes on the appropriate nodes to probe using the overlay. The user then uses -1 to 1 volt diode ramps to find the correct nodes and ensure good electrical contact. Once this is done, tests are run on a parameter analyzer with the user interface in Multiscan. The user can land the tips onto the surface in seconds and be probing the failure site within minutes, all using Multiscan software.